for Informatics and Mac. It is from Codeforces now 932 for Div 2. It is 1200 rated on Codeforces. So let us just go through the problem. So what we are given in the problem is that we have been provided with an array A and we have to just divide it into the subsegments. Now we have to make sure that the number of subsegments we are dividing, the mix, which is maximum excluded, should be same for all of those. Now what is a mix? The formal definition for mix, it is the smallest non-negative integers which is absent in the subsegment. If you take the example of 2, 2, 1, we can say that the smallest non-negative integer is 0. So the 0 is missing in this sequence, so its mix is equals to 0. If I take the example of 3, 1, 0, 1, so what is we can observe? We can observe that 2 is missing, so the mix is definitely 2. And likewise we can just see the mix. The main intuition is we have to divide it into k subsegments. Now if you observe carefully, I would like you to take an example of a simple test case. Let me just take you through the test case. Yep. 3, 2, 1, start. So if you see the example, how many segments do we need to actually build? If you observe carefully, let us say that the subsegment, we are just going to divide it out, right? We are dividing it 1, 2, 3, 4, 5, 6. You need to make sure that it is continuous in nature. Likewise, if the 2 is missing from here, the mix could have been become 2. We need to make sure that we are looking for the contiguous array 0, 1, 2, 3, 4, 5, and we are also having 0, 1, 2, 3, 4, 5, 6, and we are having 0, 1, 2, 3, 4, 5. It is an entire single array. Don't take as 3 arrays. It is only a single array only. Now if you observe carefully, if any of the contiguous system becomes more than the previous system, let us say it is up to 5 and here it is up to 6, now it is a blender, because if the 6 is present, then definitely you can see that the mix is going to become 7 for this case, and it is 6 for this case, it is 6 for this case. So we need to make sure that 6 is not present, or you can say the 7 could be present over here. It won't affect the answer because 7 is a jump from 5. It is not contiguous, so the answer still remains the 6. But if the 6 is specifically present, then definitely we are going to return a -1. As you can also see the formal input and output, we have to return the number of subsegments we are creating and from which L to R or from which index we are creating it. We have to report that out, and if it is not possible, we will simply return a -1. So in this case a -1 will be returned. Now let us assume that all of these segments are contiguous and are equal. Let us say all of these are up to 5. Now let us just remove this 6, and what do we need? We see that we actually need only 2 partitions. If you observe carefully, let us say 0, 1, 2, 3, 4, 5, it is 0, 1, 2, 3, 4. If the sub array is smaller than the previous array, let us say it is up to 5, and we can see over here it is up to 4, it won't affect the answer anyhow. We can include this smaller portion into this segment, right? Because we are having a 5 over here, we can include this 0, 1, 2, 3, 4 into this, because the frequency is not affecting the answer. So if you see, up to this, up to this, up to this, we observe that we only need to create 2k, because answer is not demanding us to do the maximum number of k or minimum number of k. It is just telling us to find any k, but it is strictly given that k must be greater than 1. So we will assume that k is equals to 2. Now if you see, we can just include all of these small portions 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5 into just this. Now what are the dots? These are representing the non-contiguous number. Let us say after this 5 we are having an 8, a 9, a 10. There is a jump from this 5, right? There is a jump from this 4, there is a jump from this. So you can clearly see that we can include all of these into a single system, and after that we can just see, can we create 2 systems? Can we create 2 systems? Now how we are going to create it? what we have to do, we have to just solve the problem in bgo of n, and for solving it in bgo of n, I will need to create a prefix mix and a suffix mix. Now what are these? These are basically the arrays, you can say, we are creating just to figure out how the answer is going to come, because we have to reduce the complexity as well. So how we will create the prefix mix? We will simply use a map data structure. First of all, the map is going to include the numbers which we are seeing. It is basically a hashing, you can say a simple hashing frequency curve. Yes. Now let us say we are getting 0 1 2 3 4 5. Now in the increasing order there is no problem, because let us say we encountered a 0, the suffix is the, let us say we are creating the prefix 1, it is updated to 1, it is updated to 2, it is updated to 3. The main problem is, let us say we have started from this section 1 2 3 4, and the 0 is coming in the later stages, but the 0 is still there, and it is a single subsegment, right? Do not consider it as 2. We will talk about the 2 later on. Let us say it is a simple subsegment, and the 0 is coming in the later stages. Now you can see clearly that we can miss out this answer. Let us say we have just started from here. If we have just started, let us say we are seeing a 1, it doesn't mean that the answer is 0, as the lowest non-negative integer is 0. 0 could come in the later stages, so that's why we have used the map data structure. Now as we move on, we will use a simple while loop. While the frequency of the current, let us say current mix, we are having an integer. I will also make sure that I show you the pseudocode for the better understanding. Let us say while current frequency is greater than 0, then we will do a current plus plus, and we will look for the later stages. Let us say we have encountered the 0. Yes, we have just excluded these portions, and we have encountered a 0 over here. Now as soon as the 0 is encountered, because we will keep this current as 0 initially, and let us say it has been met. Now we will see if its frequency is more than 1 or not. The frequency is definitely more than 1 up to this stage, and it will just basically going to increase the current by 1. Let us say we have seen the 0, and the current will be updated to 1. Now we will see, is there a 1 stored previously? Yes, the 1 is stored. It is updated to 2. The 2 stored previously? Yes, it is updated to 3, and so on. We can just find the answer in a real quick and update the prefix sum. Similarly, we can also do it for the suffix. Let me just show you the pseudocode for a better understanding. Now if you see the pseudocode, what we are doing, firstly just let us take the integer t, the number of test cases from the user, then we will use the while t minus minus to proceed into the test cases, and now we will take the integer n, which will correspond to the number of elements of the array, and just we will get it from the user array a, right? Now after that we will declare the prefix mix and prefix suffix mix, right? These are going to be an array which are currently storing up to this mix, the answer is this, right? Up to this index the particular mix is this. These are going to store that. Now we will using the current mix as 0 initially. Let us just try to create the forward one. We will using the 2 frequency curves for each forward and backward tracking. So we are using a frequency forward, initializing at n plus 5 comma 0, because let us say the answer is definitely, the maximum number is n. It can be just more than n plus 1 are needed, but let us just create for a safer side n plus 5. Now it is the important portion, the main construction of the prefix mix. We are going from index 0 to n minus 1, and we are just increasing the frequency up to this index, right? We have encountered the particular system or particular number, and we have just increased its frequency. Now after that we'll use a while loop. While frequency of forward of the current mix is initially set to 0, so it won't initialize or it won't trigger until the 0 is met first. Up to that index the answer is 0 only. Let us say 0 is met at the 4th index, so up to the 4th index the current mix is definitely going to become 0 0 0 0. This will only trigger out when the 0 is met, because 0 is kept initially. Now the 0 is met, it will look for is 1 is over there, is 3 will be there, is 4 is going to be there, and the answer will be updated vice versa, and just we will get the prefix mix. Similarly we will just do for the backward also, suffix. Now the main portion, let us just do the creation of partition. We will use the integer partition of -1. Yes, Now we are going from index 0 to n minus 1. We will see that up to this index I is the prefix mix is equal to the suffix mix from index I plus 1 to n. And if the answer is valid, we will just use the partition variable and we will just declare it and we will break the loop. Now if the partition is equals to minus 1, we will simply see out a minus 1, else we will just print out the formal input and output. Firstly, the k number of partitions, it is 2. For each case it will be 2 only, right? After that, 1 from index 1 base indexing, we have converted into the 1 base indexing. The 1, then a space, and that a partition plus 1, because the index to just convert it into the 1 base indexing, I have used it. And from partition plus 2 up to the n. I hope you understand this solution. Thank you.